What's good, 10:05 mathematicians? Mr. Herman here, back at it again. And this video is lesson 5, exercise 9H, which can be found on a separate sheet from a different textbook. You can find this in Compass or Microsoft 365 in our Teams Files tab. We're going to be looking at how to construct stem and leaf plots and what they are and why they're useful when it comes to numerical data. So to put some context to it, a stem and leaf plot uses a stem number and a leaf number to represent data. So there's two different sections, a stem part, which is here, stem number, and a leaf number. When we get numerical data, we take a number and we can extract a stem from that number and a leaf from that same number. It really depends on what type of numbers you use, and this will determine what the stem and what the leaf is. The data is broken up in two parts, and there's also a third part to it called a key, and this tells you how the stem and leaf plot is to be read. Okay, and this depends on what type of data values, whether you have numbers in tens, numbers in hundreds, decimal numbers. The key is an important function. How you write that key, I will show you that skill set in the example, on the two examples. And the graph, this plot, it's similar to a histogram. So remember, a histogram is when we have numerical data. We chunk the data up into intervals. There technically should be no gaps there. It's similar to this, but it's kind of flipped onto its side like this. And the cool thing about stem and leaf plots is that when we put histograms in, we've got these interval chunks, and that tells you the frequency of how many numbers lie within that interval. So for instance, if this was 50 and this was 60 within that chunk, and this frequency up here, say, was 20, a histogram will tell me that 20 numbers lie in between 50 to 60. But the only problem with that is we don't know what those numbers are. Specifically, we don't know what those numbers are. Heck, there could be 19 51s in there and then a random 59 to make the 20. So we're assuming that there's this even distribution that goes across like 50, 50, 51, 51, 52, 52, etc. But that not might be the case, where when we make a stem and leaf plot, the numbers will be plonked here and you can still see more or less a distribution within here. Okay, so numbers will be listed in here and you can also see an overall shape. Okay, think of this part here as your intervals, but we'll get to what these numbers should be in a second. Now, not every single data set should be made into a stem and leaf plot. It really depends on the variability of the data or how far stretched the data is. But if the data is relatively within a nice even distribution where it's not too much or not too little, then a stem and leaf plot is perfect. So the two types of characteristics we can talk about within a stem and leaf plot, and we can also talk about this in histograms, is symmetrical data and skewed data. So symmetrical data will produce a graph which is symmetrical about the center, or in other words, it is even when we are to see the amount within each interval, where it slowly tapers up and it grows and it reaches a peak and then it goes back down again, kind of like a curve ball or curved bell. Where skewed data will produce a graph which includes data bunched to one side of the center. So either it can look like this and bunch up towards the end, or bunches up at the start and then tapers off. Now these three lines will not make sense until we actually make the stem and leaf plot, and you can see these characteristics, because there will be a question asking you what's the type of the type of data that we have. Describe the type of data. So let's look at our first example. We're going to consider the set of data here. We don't know what the context is. It does not matter. All we know is that there's a certain amount of data points in decimals, okay? So you got to remember that these are decimal numbers. We're going to organize this data into an ordered stem and leaf plot. We're going to find the median, we're going to find the mode, and we're going to talk or describe about this data, whether it's symmetrical or whether it's skewed. So how do we organize the data into an ordered stem and leaf plot? The very first thing you do is when you create your stem and leaf plot, you always chunk it up by 2 lines. The first line, obviously a vertical, but the second line, the horizontal, it's on the top left here. You make a room, and quite a lot of room, to the right hand side here. Now, if you don't know what I mean by making a lot of room, I'll show you when I actually put these titles in. I'm just going to create a new layer. Here we go. So we have our stem and the leaf on this side. Now before we get to the explanation of this, I'm going to look for 2 characteristics within the data set. I'm going to look for my lowest number, and I'm going to look for my highest number. Okay, let's look at the data set and let's look for the lowest number. Looks like 0.3, no, we got a 0.1. If 0 is a data point within here, that will be considered the lowest. Okay, 0.1, and we've got 2 of them, and this is going to be an important feature, but for now, we will write 0.1 as our lowest. And the highest, 4.1, 4.6, 5 is a 5.7, 6.3, 6.8. Looks like to be our highest from here. Yep, 6.8. I don't think there's anything higher. That was very quick. There's no 7. No. Good thing I double checked. 7.5 is our highest, and this is a very important feature to know that 7.5 was the highest. Okay, 7.5. Now I could just look at the solution, but I'm going to tackle this question just like you are. Okay, so I'm going to look for the lowest, and we're going to look for the highest number. Specifically, we are going to look at the first digit of the lowest and the first digit of the highest. Don't worry about that decimal point for now. This 0 and this 7, this is going to dictate our stem list. So the lowest is 0, and we're going to put every single number in between 0 to 7. Try to make it as evenly distributed as you can. If you're going to be doing this into your exercise book, obviously use each line as a guideline. This stem just talks about, or the set of stems just talks about this group here starting with 0 point, okay? And then this group here starting with 1 point. And what we're going to try to do is find every single category for each one of them, and whatever the number is after that decimal point for that number, we're going to represent that as the leaf component. So in other words, we're going to look for all the numbers that we have starting with 0 point. So we go to 0.3, and what I tend to do is I just underline them. We've got a 0.3, we've got that 0.1, we've got another 0.1, and I think that is all of our 0 points. Yep, so we got 3. Then, not in the order that we found them, but rather in the numerical order, we are going to list the numbers after the decimal point. We don't necessarily care about the 0 points because this has been considered as our stem. So our leaves in this case, we've got a 1, another 1, and a 3. So with a leaf, we're going to put a 1, we're going to put another 1, and then we're going to put a 3. I'm not going to separate them by commas, and I'm going to try to evenly distribute them out. I'm not going to bunch them together or really spread them out because we don't have enough space. But nice even distributions all the way along for each stem. This will help us with dictating what type of data we have and describing this data. Once I've got this listed down, I'll go ahead and cross the numbers, And then I go to my second part. Now, just to make it easy for me, I'm gonna just erase those lines that I've underlined. Okay, the next thing I'm gonna do now is, now that the 0 point numbers are being crossed off, I'm gonna look for the 1 point numbers. So numbers starting with 1 point. I'm gonna underline those numbers. So 1.4, I'll actually underline them in red, can be consistent. 1.4, 1.0, and another 1.0. All right, so we've got 3 1 point numbers. And then again, starting with the lowest numbers, we've got 0, we have another 0, and we have a 4. We'll cross those 3 off. And we just keep going along until every single number is filled out. And that is pretty much how you construct a stem and leaf plot. I'm going to pause this video for you guys, and then when you come back, you'll see that this stem and leaf plot will be completed. Oakley dokley. Love software editing. They should be able to edit this out. We have now constructed our stem and a leaf for this set of data here. And what you should notice is that the distribution is nice and even within the numbers. I did make a mistake. I actually forgot about the 3.0. You can see here I didn't underline it, so I had to erase that. So just be very careful when you make your stem and leaf that you don't miss out on any numbers. That way you can you don't have to start this whole column, or row rather, again. Now, once we have done this, a stem and leaf plot is not complete without the key. Without a key. Now, what is a key? The key, this is what you will just write in a box on the side, and you'll write key is equal to. Then you're going to choose any stem and leaf number. So in this case, I'm going to choose maybe 4 and that 1. So I'm going to do the 4. I'm going to draw that line, which is this line here, to show that it's separating the stem and the leaf. And I'm going to draw the 1 as the leaf. And all I'm doing is I'm saying, okay, if I were to interpret this 4 and the 1, some viewers might read this and say, oh, so that 4/1 actually means 41. But no, that isn't the case, because the context is in decimal format. So this is why we have a key. So the key just shows the audience of whoever's reading the stem and leaf to say, hey, look, this 4/1 actually means 4.1, not 41. In some other subjects, you might have what's called a unit, and some textbooks traditionally use unit. And then with unit, I'll just put it in the side here. The unit is given as decimal points, or 0.1. This is another format to show that the units of the data here are in decimal points. If these decimal points were maybe 4.63 or 9.88, then you will put the unit as 0.01. But right now you don't have to worry about that. All you got to care about is this key. 4/1 is equal to 4.1. You can choose any number within your stem and leaf. So maybe you can choose a 2 and that 4 there, and say 2/4 equals 2.4. Doesn't necessarily matter, okay? The key is just an indicator to the audience what type of unit we're talking about. So this is A. B, find the median. So our B, remember, median is the middle value, and we gotta just double check how many units do we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 28. So our N is gonna equal 28. This is an even number, so I know that the two middle values are going to be the 14th and the 15th. Now, how I knew that is I got 28 and I split it into 2 parts, and half of 28 is 14. So right in the middle of this will be the 14th value, and we want to look for 14 and the 15th number. Okay, so 14 and 15 is going to be the median, so we have to take the average of the 14th and 15th. So let's look for the 14th. 1, 2, 3. Now, notice I didn't count the stem first. I actually just focused on the leaf part. I don't want to count the stem because this stem here is just a representation of the number starting with that digit. So if I count that stem, that is assuming that I've just counted a number value that is 0, then 0.1, then another 0.1. This isn't the case. There are no 0 values in here. There are numbers starting with 0, okay? But there's no just 0 or just 1 by itself. There is 1.0, but if I count this 1, it's assuming that there's also another 1 in there. So be very, very careful. You count your leaves, you don't count your stems. So 14 and 15th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So, to answer this question, we know that the median value lies in between 3 and 4. No, not 3 and 4, 33 and 34. Why 33 and 34? Because you gotta remember, the stem is 3, 3, and 3, and 4. So I purposely made 2 mistakes. The common one is showing that people interpret this as 3 and as 4 and they forget about the stem. And the second mistake I purposely put in is we have to remember the unit we're talking about. So it's in the middle of 3.3 and 3.4. So in this case, the median is equal to 3.35 because this is in the middle of 3.3 and 3.4. The question C, the mode, remember, just means the most common. So a mode, which number is the most common out of this data set? We can see here that 4/1 or 4.1 is the most common number, which ironically happens to be a key number as well. Well, not really ironic, it's just maybe coincidental. Now D is talking about describing the type of data in regards to its skewness. If it's symmetrical or is it skewed? In this case, we can have a look here and see that it starts off, it hits the peak within the 4 point category, and then it tapers off again. It's actually in the middle. The peak kind of reaches more towards the high end just by 1 unit. So you can write that this data description is symmetrical or relatively or approximately symmetrical. Okay, it's not exactly symmetrical, it's approximately symmetrical. But if you write the data is symmetrical, because it's just asking either whether it's symmetrical or skewed, you don't need to put some more information within this, not necessarily, just write it symmetrical or not. When you get it to year 11 general maths, if you're attempting year 11 general maths, then you will talk more about the symmetry, whether it's approximate or not. But in this case, you're just going to say that it is symmetrical. Data is symmetrical. Now, that is how you create a stem and leaf plot. Nothing too tricky about this. And then you can see here these different types of lines that I was talking about initially. Kind of looks like a face that I'm drawing there. This is what you can see within this line here. And the first fact that one of the facts, sorry, here, the graph is similar to a histogram, a psi, or a bar graph with class intervals, but there is no loss of detail in the original data. I can see the shape, I can see the popularity, I can see the most common number, I can see the median, I can see the mode. There's so much information that I can extract by taking these decimal numbers right here and putting it into a stem and leaf plot. It's a nice way of displaying information. One of my favorite ways, to be honest, and it's actually quite simple to do. With this, we can also create back-to-back stem and leaf plots. And a back-to-back stem and leaf plots are pretty much two stem and leaf plots that we create using the same stem, the leaves will not only be on the right hand side, but on the left hand side, depending on what categories we have. In this case, we have two categories for this example. So let's have a look at this example. Shop owner has 2 jeans shop. The daily sales in each shop over a 16-day period are monitored and recorded as follows. So shop A after 16 days will have these amounts. Ooh, 3, ooh, must have been, I don't know, some type of game happening next door. Wow, 3, it's not that many jeans if you look comparatively speaking. And then shop B may be a smaller shop by the looks of it, because not as many sales, there's a lot of single digit sales. Maybe this day it was quite popular, 27, maybe it had a, yeah, I don't know, I'm rambling here. But you can see I'm going into this mode where I'm just making assumptions straight away about the information here. It's just what I tend to do. But we want to be able to put this in a form where we can say wholeheartedly what type of information we can extract, and this is where we can create a stem and leaf plot. And specifically, we're going to create a back-to-back stem and leaf plot with an interval of 10. With an interval of 10. This interval of 10 just means that the stem numbers are going up from smallest to largest by 10 or by 1, as you'll see here. First thing we're going to do is we're going to look at the lowest and the highest number again. And in this case, we're doing it just to help us guide us into where our stems are going to start and finish. And we have to include all the digits, not just one category, but all of it. So we're going to look at all of the digits together. The smallest number is 3. And I'm going to be very specific in the way I write this. I'm actually going to write 0, 3. Okay, it still means 3, but I'm purposely putting this 0 here to help us dictate what type of stem we're going to have. And then the highest amount in this case is 28. So our stem and leaf plot for A, there we go. Stem and leaf plot. We're actually not going to put the stem on the side here. We're going to write stem in the middle, meaning that the lines that we draw are going to look like this. There's our first one. And it's not going to be that many because it only goes from 0 to 2. There's a second one. Let's try that again. There's a second one. There we go. And the line that goes across looks like that. So now we've included this extra line, and the positioning is going to look a little bit different. And the reason why is because we're getting two sets of information. So the stem stays in the middle, and we've got a leaf, and we've also got our other leaf here. Okay, stem smallest 0 starts at 0. Interval of 10 meaning it's going up by units of 10. So we start in our tens, units starts at 0, and then it just goes 1 and 2. Now you would think that this type of information seems redundant, seems kind of pointless, but if this said that we wanted an interval of 5, we would chunk them up by 0 to 5 and then 5 to 10. 0 to 4, sorry, and then 4 to 9. So we would have 2 stems of 0s, then 2 stems of 1, and then 2 stems of 2. That is assuming our interval is 5. And in this case, it's 10, so we're just going up by 10s within our stem, or a 10s unit. Now, leaf, this leaf here is going to be for shop B, and this leaf here is going to be for shop A. So I'm actually going to put down the leaf numbers for B first, because I know how to do this from the previous example. And luckily this set of numbers are ordered already from smallest to largest, so there's no point in having to underline them. I already know that it's going to start at 4, and it's going to go 6, 6, 7, 7, 8, 9, 9. Should have drawn that line a little bit bigger. Then we're going to go 10, 10, 12, 13, 14, 14, 16, and 17, and then we've got one digit, 27. Okay, so there's the first one. Don't worry about a key for now. I'll get to that in a second. But now we're going to look at shop A, but this time our leaf is going to go from smallest to largest, but going that way. Okay, it's going that way. So in other words, 3 here, we're going to read this for shop A as 3, not 30, but 3. So when we look at the left side of a stem and leaf plot, we're reading it from right to left as opposed to left to right when it's on this side here. So you've got to be very careful with this. Next ones, we're going to have 2, 2, 3, 4, 4, 5, 5. So 2, 2, 3, 4, 4, 5, 5. 21, 22, 24, 24. So the breasts are all on the 2s. So 1, 2, 4, 4, 4, 6, 7, 8. 6, 7, 8. And there's our back-to-back stem and leaf plot. Now, when it comes to writing the key, I kind of have a little bit of a disagreement in regards to the way that the textbook writes the key out, because they write the key just for the B part, for the B shop. So we'll take a normal 2/7 is equal to 27, in this case, what, 27 sales? But this is making the assumption that it also is applied to the other side, which isn't necessarily the case because we're reading the other side back to front. So to compensate for this, I tend to write another key for the other part, and I'll just write 3/0 is equal to 3 sales. And this is just for the other part, okay, so for A. Because remember, the key is purely there just for the interpreter or for the reader to be able to interpret this information properly, okay? So if you use just this, that seems not as much information that is recommended for the reader, okay? This is my honest opinion. Now that we've got our two different stem and leaf plot, or back to back, we're going to compare and comment on differences between the sales made by the two shops. So what type of assumption can we make? What type of information can we extract from this back-to-back stem and leaf plot? Now I'm not actually going to write this information down because it might take me a while using this tablet. But what I can say is very, very basic, is that shop A had the most sales. Comparatively speaking, the most sales for shop B was 27 and for shop A is 28. So the most sales between both shops is shop A with 28 sales. Second thing you'll say is that shop A's sales generally ranged between 12 to 28. So the general range is 12 to 28 with an uncommon sale of 3, which is, you could consider it an outlier if you were to work that out, looking for the lower and higher fence. That's enough about shop A. Shop B, you can say that their sales generally range between 4 to 17, with one of their sales, or one of their odd sales being 27. Maybe they just had a clearance sale on that day, who knows? But that's all you need to do to describe the information extracted here. You could also talk about the skewness, where it is both skewed, both sales are skewed, and that's specifically because of both of them having these outliers, one having a very low sale, shop A, and one having a very high sale, shop B. So you can say that it is skewed, it's not symmetrical. And that's it, that's all you have to talk about in regards to the differences between the two. You could make the assumption that shop A is more popular in regards to their sales because most of their numbers are within a higher chunk as opposed to shop B, which is in a lower chunk. That's safe to say as well. And that concludes this lesson of SEM and leaf plots. I forgot what we're talking about. SEM and leaf plots, lesson 5. Go ahead and download the 9H sheet. The questions that you'll be doing here, depending on what skill set, can be found here. Go ahead and attempt these questions. And the last video will be about box plots, which will be in the next video. Until then, catch ya.